Assalamu alaikum and welcome to Cambridge Chemistry channel with Sarwat Ahmed. I will be solving this paper for O-level students who are appearing in alternative to practical paper in this year. So this is paper 4 alternative to practical May-June 2022 and paper 4-2. Question number 1. Iron tablets are used to treat iron deficiency in the body. Iron tablets contain iron 2 ions. A student does a series of titration with aqueous potassium manganate to determine the percentage percentage of iron in some iron tablets. Diagram of some of the operators the student uses are shown. This is the redox titration. This is iron 2 salts and this is potassium manganate. Potassium manganate act as an oxidizing agent while iron salts act as a reducing agent, as you have done in redox topic, that iron salts always act as a reducing agent and potassium manganate act as an oxidizing agent. Now diagrams of some operators the student chooses are shown. A, B and C. A is burette, B is measuring cylinder and C is pipette. A is burette, B is measuring cylinder and C is pipette. The student records a total mass of 5 iron tablets, crushes the tablets, dissolves them in distilled water and makes the solution up to 250 centimeter cube. Uses apparatus C to transfer. Apparatus C is the pipette. Transfer 25 centimeter cube of the solution of iron 2 ions into conical flask. You know about the conical flask. This is the conical flask. So uses apparatus B to add 10 centimeter cube of dilute sulfuric acid to conical flask. Uses apparatus B to add 10 centimeter cube of, this is apparatus B measuring cylinder, to conical flask. Fills apparatus A with 0.00500 mole per dm cube KMnO4 aqueous. A is the burette, so burette is potassium manganate is filled up in the burette. Titrates the solution of iron 2 ions with 0.00500 mole per dm cube KMnO4 aqueous until the first permanent pink color is seen. This is the end point. Repeats the titration 3 times. Now the equation for the reaction is shown. MnO4 minus plus iron 2 plus 8H iron to form manganese. This is the redox titration. You know that manganese in manganate getting plus 7. You know how to calculate oxidation state of manganate ions. MnO4, this is minus 1, Mn plus oxygen atom of 4 atoms of oxygen, oxygen carrying minus 2 charge is equal to minus 1, Mn minus 8 is equal to minus 1, so Mn is equal to minus 1 plus 8 is equal to plus 7. So carrying plus 7, so this is Mn2 plus, so this is going to reduce. And iron 2 going to iron 3, so this is going to oxidize. Suggest why dilute sulfuric acid is added to the conical flask to provide H positive ion. So redox titration is carrying out in acidic medium or alkaline medium. So H positive provides acid ion. Give the formula of the ion responsible for the pink color seen at the end point. Formula of the ion responsible. Manganate is responsible. This is the formula of ions. Now the diagram show parts of the apparatus A with the liquid levels at the beginning and the end of the titration 3. This is the initial reading and this is the final reading. So this is the reading of this is only one reading is given and you have to complete the third column. So this is initial reading. Final reading is 17.1. So this is 17.1. This is 17 and this is over here 17.1. So this is 17.1 and this is 0 and 0.7. So this is 0.7. So let's calculate the volume difference. 17.2 over here and 16.9. This the difference is 16.9 and the difference, this is the result value is given and we can find out the difference between two values, that is equal to 0.2. So the best titration, you know that the readings which are closer to each other, which have very little difference between two readings, those are the best titration. This is 16.4, sorry. This is 16.4. So the best titration, the 16.7 and 16.4. There are three difference, 16.7, 16.9. So these are the two closest reading. So these are the best titration. And if you fill accurately this table, you get 3 marks. So please be careful while solving this, while filling this table. Take the best titration results in the table. Use the ticked volume values to calculate the average volume of 0.00500 mole per dm cube KmNO4. So average volume is equal to best titration 16.9 plus 16.7 divided by 2. So the best titration will be 16.8. A second student does another series of titration using the same method and 0.00500 mole per dm cube. This is second student does another series of titration and the average volume of this by this second student is 16.9 centimeter cube. The equation for the reaction is shown. Calculate the number of moles of manganate ions used by the second student. So we have concentration as well as volume. Okay, by using this formula, mole is equal to concentration into volume or divided by 1000, because volume is in cm cube. So this is 0. Is equal to 0.0050 mole per dm cube. Concentration multiplied by volume is 16.9 divided by 1000. So this is equal to 8.45 into 10 raised power 2 minus 5, or you can write down like this: 0.000845 mole. Calculate the number of moles of iron 2 ions present in the 225 centimeter cube of the now iron. This is the potassium manganate ions. Please write, this is manganate ion, and this is the chemical equation, that 1 mole react with 5 moles of iron. So by using mole ratio, MnO4, iron 2 ions, so this is 1 mole and 5 moles and 0.000845 moles ratio X. So the mole of iron is 4.225 into 10 raised per 2 minus 4, or we can write down 0.0004225. Calculate the total mass of iron ions in the 5 tablets by using mole is equal to mass over AR. So mass will be equal to mole into AR. So mass is equal to mole is 0.004225 into AR 56. The answer will be 0.0237. The total mass of the 5 tablet is 1.83. Calculate the percentage by mass of iron in the tablet. Give your answers to 3 significant figures. Percentage of iron is equal to mass of pure iron, which we have calculated, is 0 point, and mass of impure which are used in titration, impure iron. So mass of pure iron is 0 point, which we get 0.0237, and impure iron is 1.83 into 100. The answer will be 1.29%. So these are the 3 significant figures. So this is all about of this question. Hope you understand. A solution contains cations and two different anions. The table shows the test a student does on this solution. Complete the table. Name any gases formed. To portion of the solution a boiling tube and add aqueous sodium hydroxides. The conclusions is the solution contains iron 2 ions. It means green precipitate. We know that iron 2 ions form green precipitates when it reacts with sodium hydroxide. When iron 2 ions react with sodium hydroxide, it forms green precipitates. Green precipitates of iron 2 hydroxides. So this is the reaction. You can look at this reaction. Iron 2 ion, any iron aqueous salts you can use. Yes, plus sodium hydroxide to form iron hydroxide plus sodium sulfate. So this is chemical equation. So that's why this is aqueous, and iron 2 hydroxides are solid, and this is aqueous. So green present, and iron 2 hydroxides is green in color. So the observation will be green precipitates of iron 2 hydroxide is formed. To portion of solution in test tube and dilute nitric acid until no further change. Test tube, add dilute nitric acid until no further change is seen. Keep the solution for test 3. A gas is evolved that turns lime water milky. This is observation of carbon dioxide gas, so it means this solution contains carbonate ions, and gas is evolved that turns lime water milky. It means 2 marks, carrying 2 marks. So first mark is of that carbon dioxide is formed, carrying 1 mark, and if carbon dioxide is formed in the solution, so it means that solution it contains carbonate ions, carrying second mark, carbonate ions. Add aqueous barium nitrate, a white precipitate forms. So this is the test of sulfate ion, please keep it in mind. And this is test of carbonate ion, and this is test of iron 2 ions. So just identify that from the observation and from the test you can identify the test of cations or anions. Add aqueous barium nitrate, a white precipitate forms. It means this is barium nitrate, a white precipitate forms in this solution. It means this solution contains sulfate ions. If white precipitate forms, it means it contains sulfate ions. So white precipitate forms, solution contain sulfate ions. Calcium ammonium nitrate. Next B part is calcium ammonium nitrate is water soluble compound. Describe a series of tests and the observation to identify the calcium, ammonium and nitrate ions in a sample of calcium nitrates. So first identify that how many cations and anions are present in this salt. Calcium is positive ion, ammonium is positive ion and nitrate is negative ion. So dissolve a sample. Your description will need to explain how to prevent ammonium ions interfering with the test for nitrate ions. Dissolves the salt in distilled water and then carrying out test by one. Test for calcium ion, and aqueous sodium hydroxide and warm. This is test and observation will be white precipitate, white PPTs or insoluble white PPTs of calcium hydroxide, which is insoluble in excess of sodium hydroxide. This is test of and now next cation is ammonium. So test of ammonium ion. Add aqueous sodium hydroxide and warm the solution. Observation. A gas with pungent smell is produced, which turns damp red litmus paper blue. Which shows, or this test confirms the ammonium ion, NH4 ion. Next test for nitrate ions, NO3 ions, and aqueous sodium hydroxide and warm. Gas is given off weight that gas wait till no more gas is given. Then add aluminium foil and warm the mixture. And warm it. Ammonia gas is a gas with pungent smell is again given off which turns damp red litmus paper blue, which confirms nitrate ion. Next, name the process used to separate ethanol from a mixture of ethanol and water. Ethanol and water are miscible liquids, so the process which is used to separate is fractional distillation. This is a fractional distillation. Fractional distillation is used to separate miscible liquids on their boiling point. means ethanol has lower boiling point than water, so ethanol distilled over earlier than water, so that's why fractional distillation is used. As ethanol and water have different boiling point, ethanol has lower boiling point, so boils earlier. Describe a suitable method in each case to separate the named substance from the mixture. Explain your choice in each case. Pure dry sodium chloride from a mixture of sodium chloride and sand. Sodium chloride is soluble in water while sand is insoluble. The filtration is used. So how to explain this? Add water in the mixture and stir. Heat the solution to ensure all sodium chloride get dissolved. Filter the solution. Filter the solution mixture to separate sand as a residue and heat the filtrate to remove. Heat the filtrate to evaporate water. So add water and mixture and stir. In the mixture and stir, carrying 1 mark. Heat the solution to ensure all sodium chloride get dissolved. 2 marks. Filter the solution mixture to separate sand as a residue and heat the filtrate to evaporate sodium chloride to evaporate water. Carrying 3rd marks. Food coloring from mixture of 3 food colorings. So using chromatograph, spot the colors, spot the food colors on chromatography paper. Sort of filter paper. Dip this paper in the solvent to ensure that solvent level is below than baseline. Calculate the RF value of the food colors to identify the distance traveled on the chromatogram. A student suggests a method to prepare pure dry crystals of highlighted copper 2 sulfate, but some processes are missing. Measure a known volume of 0.5 mole per dm cube sulfuric acid into beaker. Add a spatula measure of solid copper 2 oxide and stir. Heat to evaporate all water and obtain the crystals. There is a process missing between step 1 and step 2 to increase the rate of reaction. So we need to warm the acid, so heating is required. Heat or warm the acid to increase the rate of reaction. In step 2, all the solid copper 2 oxide disappears. State and explain what the student should do next in step 2. Measure of solid copper 2 oxide and stir. Filter the solution. Filter the solution to remove excess of copper 2 oxide. Now this is the step 2. Step 2, this is not step 2. Step 2 is keep adding copper 2 oxide in excess until black solid remains in the bottom. We are using excess copper 2 oxide to ensure all acid is used up. Copper 2 oxide is used in excess to ensure all acid is used up to prepare pure copper sulfate salts used up. There is a process missing between step 2 and 3. Identify the missing step. Now filter the solution. Filter the solution to remove CuO, to remove excess of copper 2 oxide, to remove excess of copper 2 oxide. as a residue. Step 3 will not make crystals of hydrated copper 2 sulfate. State and explain how the student should change. Step 3 to make pure dry crystals of concentrate the salt solution, concentrate the filtrate by heating but not till dryness. You can write down till saturation point or till crystallization point, but not till dryness. Allow the crystals to cool. Allow the crystals to cool. And dry in 3 folds of filter paper. So this is all. Describe 2 observations the solvent makes during the preparation of pure dry crystals of hydrated copper 2 sulfate. For each observation, make clear at which step it is seen. Observation 1. Step 2. In step 2, black solid remains, copper 2 oxide remains because we are using excess of copper 2 oxide. Black solid remains. And solution turns blue. Copper 2 sulfate, because all copper salts are blue except copper 2 carbonate, which is green in color. So and solution turns blue. In step 3, blue crystals can be seen. Blue crystals have been observed. So state an hazard involved in this preparation and safety precautions the student should take to reduce the risk from this hazard. Because we are using acid and acid is corrosive, heating is involved, and if acid is corrosive we can use safety goggles, and because heating is required we can use gloves, and copper salts are toxic. Should not taste the salt. So a student does an experiment to determine the enthalpy change for the displacement reaction between zinc and copper 2 sulfate. Zinc plus copper 2 sulfate to form zinc sulfate. This is displacement reaction. State what is observed during this reaction. What is observed during this reaction? You know, zinc is copper 2 sulfate is blue in color, zinc sulfate colorless solution, and copper pink solid. can be seen. So blue solution turns colorless, and other observation, pink deposits of copper. And you know that displacement reaction is an exothermic reaction. So the question shows that enthalpy change for the displacement reaction, so heat bubbles can be seen. So 1 mark, so only one observation is enough, but for safer sides you can write down 2. First 2, blue solution turns colorless and pink deposits of copper solid. Heat is also evolved because this is exothermic. Now the student weighs a sample bottle with a small amount of zinc powder. Pour 25 centimeter cube of 0.5 into a glass beaker and records the temperature. Record the temperature of the copper sulfate at 1 minute intervals for 3 minutes. Add zinc powder to the copper sulfate at the 4th minute and reweigh the sample bottle. Stir the mixtures in the glass beaker and records the temperature at 1 minute intervals for 6 minutes. The masses recorded are shown. Mass of container with zinc powder is 15.18 gram. Mass of container after zinc powder added to copper 2 sulfate. The difference will be 0.95. The results are shown 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 minutes. And this is the temperature change 22.2, 22.1, 22.1 and 29.1, 28.9, 28.7, 28.5, 28.3 and 28. So question number 1, this is 0.91, and now 2, suggest why no temperature was recorded at the 4th minute. Because as the zinc was added at 4 minutes. Suggest why the zinc is powdered. So larger surface area mean which exposed to the other reactant through on all sides. Larger surface area increases the rate of reaction. State and why the glass beaker is not the most suitable piece of apparatus for this experiment. Suggest an improvement. As glass is not a good insulator, glass is not a good insulator. Heat can escape. Heat can loss. Suggest an input. A lid on beaker, or use polystyrene cup instead of glass beaker. Polystyrene cup instead of glass beaker. So I plot the graph. I have plotted this to save the time. So you can use 22.1, 22.1 and 4th minute we add the zinc, and then temperature rises can be drawn over here. So these are the 29.1 at 5, 28.9 at 6, 28.7, 28.5 at 8 and 28.3. So we can use graph like this. Plot the values of temperature degree centigrade against time per minute on the grid. So this is the shape of the graph, you can see. Draw a straight line best fit through the points from 0 to 3 minutes. So this is the straight line. And explorate this line to the 4th minute. Now explorate this line till the over here. And draw a straight line of best fit through the points from 5 to 10. 5 to 10 points, straight lines. So the straight line like this. Explorate this back to the 4th minute. Back to the 4th minute. So this is the back to the 4th minute. And then use your extrapolated lines to determine the temperature change delta T at the 4th minute. So this is the temperature change can be there. Okay, so this will be 29.4. and now use your extrapolated lines to determine the temperature change delta T is equal to final temperature minus initial temperature. So final temperature is 29.4 and initial temperature will be initial temperature will be 29.4 and initial temperature will be 22.1. So this is equal to 7.2, round about 7.3 I think so, degree centigrade. Calculate the energy change Q in joules during this reaction. Use the expression shown. Q is equal to mc delta T, where m is equal to 25 grams specific heat capacity. So Q is equal to 25.0 into 4.2 joules specific heat capacity, and delta T is 7.3. This is equal to I have calculated this. This is equal to 767 joule. The limiting reactant is copper 2 sulfate. Calculate the number of moles of copper 2 sulfate. 25 centimeter, 0.5 mole is equal to concentration into volume divided by 1000. So 0.500 into 25 divided by 1000. So this is equal to 0.0125 mole. Use your answer from B9 and B10 to calculate the enthalpy change delta H for the reaction in kilojoule. So this is joule, Q is in joule, Q should be in kilojoule. So first convert Q into kilojoule. 767 divided by 1000 is equal to 0.767 kilojoule. So the Q delta H is equal to kilojoule per mole. Q over mole. Q in kilojoule and this is in mole. 0.767 and 0.0125. This is equal to 61.4 kilojoule. So this reaction is exothermic, so sign of enthalpy change is negative. 61 point minus delta H is equal to 6 minus 61.4 kilojoule per mole. The actual enthalpy change for this reaction is likely to be greater than the value calculated in the suggested in the B9. Suggest the reason for this difference. Actual value is likely to be greater than the value I calculated. So this is the experiment. So there are different errors can be there. That is experimental error can be, personal error can be. So the main error should be heat loss, because we are using glass beaker, and heat loss can be there. Reaction might be incomplete. As the zinc is coated. So these are the two reasons for this difference. So this is all about. Okay students, if you like this video, please subscribe, like and share this video. Okay, Allah Hafiz.